Hey there, science fans! Today we're diving into the exciting world of ultra-high-performance liquid chromatography, or UHPLC for short. It's a mouthful, I know, but trust me, it's way cooler than it sounds. Imagine you have a mixed-up bag of Skittles. You want to separate them by color, right? That's what UHPLC does for scientists, but instead of Skittles, it separates tiny molecules in things like medicine, food, and even water. UHPLC is like a super-powered microscope for chemists. It helps them see and study things that are way too small to see with the naked eye. It's all about separating mixtures and identifying what's inside. Pretty neat, huh? So buckle up. We're about to explore the amazing world of UHPLC and see how this technology is changing the world of science. Okay, science explorers, let's break down how UHPLC actually works. Imagine a racetrack for molecules, kind of like a super fast science fair project. First, we take our sample, whether it's medicine, food, or anything we want to analyze, and inject it into the UHPLC system. Think of this as the starting line of our molecular race. Next, a special liquid called the mobile phase carries our sample through a tiny tube called the column. This column is packed with special materials that act like obstacles, making different molecules move at different speeds. It's like an obstacle course for our tiny competitors. As the molecules race through the column, they separate based on their size, shape, and chemical properties. The faster ones zoom ahead, while the slower ones lag behind. It's survival of the fastest molecule. Finally, a detector at the end of the column spots each molecule as it crosses the finish line. This helps us identify what's in our sample and how much of each component is present. It's like a photo finish for our molecular race. Now you might be wondering, what's the difference between UHPLC and regular old HPLC? Well, think of it this way. UHPLC is like a sleek race car, while HPLC is like a trusty bicycle. Both can get you there, but one is much faster and more efficient. UHPLC uses much higher pressure than HPLC, which means it can push the mobile phase through the column much faster. This translates to shorter analysis times and sharper peaks, giving us more detailed information about our sample. It's like going from a leisurely bike ride to a thrilling race car experience. Plus, UHPLC uses much smaller particles in the column, which means there's more surface area for our molecules to interact with. This leads to even better separation and resolution, allowing us to see even the tiniest differences between molecules. It's like having a magnifying glass for our molecular race. So, where is UHPLC used in the real world? The answer is everywhere. From the medicine you take to the food you eat, UHPLC is helping scientists make our lives safer, healthier, and more delicious. In the pharmaceutical industry, UHPLC is used to analyze the purity and potency of drugs, ensuring that you get the right dosage every time. It's like a quality control expert for your medicine cabinet. Food scientists use UHPLC to test for contaminants and additives in our food, keeping our plates safe and healthy. It's like a food detective, making sure what we eat is up to snuff. UHPLC is also used in environmental monitoring, helping scientists track pollutants in our air and water. It's like an environmental watchdog, keeping an eye on the health of our planet. These are just a few examples of the many ways UHPLC is used in the real world. It's a versatile and powerful tool that is revolutionizing countless fields.